Okay, we are on the fourth and final part of section 4.4, derivative of log functions. This is really the second part of doing derivative of log functions. We, of course, looked at exponentials before we got into logs. So my question for you is, how do we take the derivative of something in the form log base a of x? We were looking exclusively at functions in the form natural log of x. So we're now expanding it to, hey, that base could be anything. We're using a to represent what that base is, and we are going to figure out what is the derivative of that. So, unanswered question for the moment. Let's look at the function y equals log base a of x and see what we can do with it. And my thought is, let's see if we can convert that to something that we know how to take the derivative of. So I'm recalling from pre-calculus that when I have a log function and I don't have a natural log base, or a base 10, I can convert it using my change of base formula, as long as I use the same base for the numerator and the denominator. So I'm going to specifically choose to use my natural log base, and I'm going to say that that function is really, let's see if I can, whoops, y equals natural log of x over natural log of a. So if I can rewrite it as that, now I should be able to take the derivative of both sides, because I know how to take the derivative of my natural log function based on the last video. So if I take the derivative of both sides, dy dx is equal to, it almost looks like we're going to have a quotient rule here. Be careful, let's think about what we have. Natural log of x, that is definitely a function. Natural log of a. A is, remember, just my base, so a is a number. A is my base right there. But natural log of a number is just going to be a number. That's not a function, because a is some defined value. I just don't know it's representing anything, but it's not my variable. So I'm going to rewrite this function as 1 over natural log of a times the natural log of x. That was supposed to be an n, not an m. Natural log of x. So I've just separated it. You can put that over 1 if you want. I've separated it so that I can see that a little bit better as constant times function. So when I'm doing the derivative of a constant multiple, I just multiply by that. So 1 over natural log of a times, now I've got to actually do the derivative of natural log of x, and recall from my last video that is 1 over x. So my derivative ends up being, 1 over, I'm just going to combine those by multiplying my denominators, multiplying my numerators, 1 over x natural log of a. And that is going to be my pretty simple rule for when I have a log base other than e. So let's go ahead and jot that down up here so that we have a nice formula for ourselves. 1 over x times the natural log of a. And if you've been following kind of the process that we're using here, we are coming up with a rule for our function in simplistic terms. That would be when I have a simple function, so log of a simple function x. But we should be able to generalize that so that we can figure out what can we do when we have a function of the form log base a of u. And it's going to be basically the same thing, I'm just having to apply my chain rule. So this u is functioning like my x was, so I'm going to have 1 over u. Just like I had x down there, I now have u, times natural log of a. That's the exact same as what I had in my other one over here, natural log of a. And the only thing I have to do to finish that up, since I have my u function, is multiply by du dx at the end. And that's going to be my rule, my general rule for when I have a function other than x. Okay, let's look at a few examples. I think I have 3 examples for you. So what happens when I have the function? Let's consider y equals log base 5 of radical x. So I'm going to write this out, my full chain rule. So dy dx is going to be dy du times du dx. We know that from section 4.1, and we're really just applying that. So I'm going to go ahead and start by saying that my u function here is radical x, or you might prefer to write that as x to the 1/2 power. Du dx is then 1/2 x to negative 1/2, which is negative 1 over 2 radical x when I simplify that. And then I'm really doing y equals log base 5 of u, because of course I've established that that is u. So when I do derivative of log base 5 of u, now I'm going to my rule for this section that we just wrote down. Dy du is going to be 1 over u times the natural log of my a, which is 5 in this case. So my final answer for this is multiply my two derivatives. So 1 over u natural log of 5 times negative 1 over 2 radical x. Okay, and if you were going with the rule that I wrote down on the previous slide, I had written dy dx is equal to 1 over u natural log of a times du dx. So not to confuse you here, notice that my 1 over u natural log of a is my dy du, and that's what I did over here. So it's really just a matter of preference if you like our u substitution for our chain rule, or if you'd rather just substitute this straight in here, you're welcome to do that. Okay, regardless, when I get to the end of this problem, I need to simplify things up, and my u is my radical x. So I need to put a radical x in here times natural log of 5 times a negative 1 over 2 radical x. And then I'm going to multiply across the denominator, so negative 1 over 2 radical x times radical x is x, natural log of 5 for a final answer. Okay, let's try another one. Let's consider y equals 1 over log base 2 of x. I like this one because it's completely different, but we can totally handle this just using our chain rule. So let's go back to chain rule. If I'm going to define a function here and try to simplify this, I'm going to have to go y equals 1 over u, and that's going to make my u be the log base 2 of x. So previously, my u was the inside of my log function. If you go back to... Okay, I'm going to try to keep recording here, so hopefully... Sorry, tech issues. So I've got my u function, and I'm going to go ahead and differentiate that with respect to x, which is going to give me... Here's where I'm applying my new rule, which is 1 over u. I shouldn't really say 1 over u. 1 over x, natural log of a. And a in this case is my 2, right there. And then let's go ahead and do my dy du. You might want to think of this as u to the negative first power, which gives me negative 1, u to the negative second, or some of you are okay with just jumping right to negative 1 over u squared. If you're fine with that, you don't have to write it all out. So chain rule tells me I'm going to get my derivative with respect to x by taking my derivative of y with respect to u and multiplying it by my derivative of u with respect to x. And if I do that, I'm going to have negative 1 over u squared, my derivative of y with respect to u, times my derivative of u with respect to x, 1 over x natural log of 2. And the only thing I need to do at this point is substitute in for my u. U is log base 2 of x, so negative 1 over log base 2 of x. Log base 2 of x. So that's coming from this right here, substituting in for u, times 1 over x natural log of 2. And let's see, I can make it one fraction, negative 1 over x natural log of 2 times log base 2 of x. I don't think I can do anything else with that, so we will leave that alone. Kind of a crazy answer, but it works. Okay, so, whoops. Okay, so one more example. Let's consider the function log base y equals natural log of 2 times log base 2 of x. And I wanted to throw this one in there because I think this one is tricky and misleading. And the reason is that it looks like we have a product right there. So I'm starting with just kind of analyzing what is going on here. And I am thinking product rule, but look closely. Okay, this is just because we're not used to working with our log functions. We haven't used those in a while. And recall that log or natural log of a number is a constant. So I actually have a constant right here. And therefore, I'm not going to have to do my product rule. And I'm not even going to have to do a u substitution here because I have log base 2 of a simple x. So I'm just going to use my simple constant multiple rule, which tells me that if I have the derivative of something with a constant multiple, natural log of 2, I'm going to have that constant multiple times the derivative of my function. And now I need to analyze, okay, what is my derivative of this function log base 2 of x? And that goes back to our first rule for this section, because I just have a simple x, 1 over x natural log of 2. So I end up with natural log of 2 times 1 over x natural log of 2. Of course, that's natural log of 2 over x times natural log of 2. And the natural log of 2 on the top and the bottom cancel out, giving me 1 over x as my final answer for that. Okay? Hopefully that was enough to kind of give you an idea of like the flavor of what these could look like. And of course we will need to do more practice with these because I just threw at you a bunch of rules. I would recommend you have 8 rules or 4 rules if you want to consider it 4 different rules and then the general form of them. I would recommend that you start working on memorizing those, make flashcards, whatever you need to help you out with that.